To start our next drawing, go to New, pick Drawing. Again, we will receive the SOLIDWORKS template and be ready to place a part. When I click Browse, this time I'm going to choose the bolt. I again will place a front, a top, the right side, and the isometric on my drawing. After getting all 4 projected views, remove the isometric into the upper corner. Click on the front view, look at the current scale. Current scale is set at 1:1. You have quite a few dimensions to lay out for this part, and it's filling the space pretty nicely, so I'm going to leave these alone. Go to this one over here and make this one 1:2. Again, half the size of the flat views. It goes up in the corner, and I've finished with the isometric view. At this point, I am ready to dimension these. You'll notice I did leave some space below because I am going to have to break some of our should rules and put some dimensions to the outside because, as you'll see, I can't put them to the inside. Starting with smart dimensioning, I'm going to look at the height of these individual pieces. One of the really important dimensions will be the height from the very bottom of the stem to the top of the stem. So I'm going to pick 2 lines in that location and show that as the 1 inch. I'm also going to pick the diameter of the small section of my chamfered edge. I'm going to look 2 over here and say, to do my large diameter, I'm going to click those 2, placing that down below. That gives me the majority of what I need for the stem, except for my angle. I'm going to zoom in to show this individually. I want the angle of this from horizontal. So what I need to do is click the line, and then click the horizontal line nearest to it. And as long as I pull off in this direction, I'll get the exact measurement I want. If we start to go this way, I'm going to get a different measurement, different over here. Okay. I want this one right here because if you remember our chamfer settings, this was that 45-degree cut. And this is actually all the information I need for the chamfer. Knowing that this is a 45-degree cut, seeing what the result is, and what the original was, I can figure out exactly how big that is with some simple math. So that's perfect for that one. Then I'm going to come over to the right side view and use this to grab the top and bottom of my bolt. This is a much more correct dimension than picking this straight line here. Excuse me. I'm then going to use the other view, because I can keep it between the views, to dimension the radius here. Again, to show that this is a 90-degree rounded corner, we show the height of the object overall and then the radius of the corner. If we do this differently, it implies that it's not necessarily a 90-degree radius corner. This is the proper way to show that. I'm now going to turn my attention to the top view to fill in the information that is missing. The first thing I'm going to need is the overall side-to-side measurement. Bolts like this are sized by the wrench size used to turn them. That wrench size is the distance from the flat to the flat. So I'm going to go ahead and come all the way out to this line, come down all the way to this line, and pull this measurement out to the side. So if this was a bolt in real life, it would need a 1.5-inch wrench to turn the bolt. I also need to dimension the radius of my arcs here. I'm going to use this one because I can't use any of these that would be really nice between the views, but this one's pretty close. So I'm going to use this one here. And again, by only dimensioning this one here, I am telling you that all of these corners of this on this same pattern are the same. Again, by only dimensioning the side-to-side measurement on this regular hexagon, I'm telling you that this is a regular hexagon with 60-degree angles and all that, just like normal. These are all the dimensions that are required. The last thing I want to do before filling out the title block is go to Note, drag a box to make a box, tell you that the material equals plain carbon steel. Hit enter. Fill out the mass. I made an error and accidentally typed a plus sign here. Don't hold shift when you hit the equal sign, you'll get a plus sign instead. Again, you're going to go to the actual part itself, go to the Evaluate tab, and you open up Mass Properties after setting the material. And at that point, you'll be able to see what the mass of this object is. As a placeholder, I'm just going to put 0.00 pounds. Complete this drawing. I will fill out the title block. You can see a copy of this fully completed in the example packet.